And we should be live now. Hello, everyone. Welcome to our AWS session. We have a special speaker today, Jean, um, tuning in from the United States. Hey, hi, Jean. How are you doing? You have to unmute yourself. Yeah. Great.
Yes, I'm doing well, Karen. Thank you for asking about you.
Yeah, I'm also fine. Thank you. I'm excited to have you today in our session, and it's an amazing topic about DynamoDB. The stage is yours. Tell us a little bit about your topic and about yourself, and you can kick off.
Right. In this topic, I will cover kind of the best way you should handle DynamoDB thwarting exception. This is one of the issues we are facing out there. And sometimes, even though if we have auto scaling configured on the provision mode, we still face that same kind of issue. I will do a basic introduction and then explain the table structure, and then move to the main topic.
Okay, sounds great. Thank you. If you want, you can start sharing your screen.
Okay. Let me know if you are able to see my screen.
Not yet, but it takes a couple of seconds. Let's wait a little bit. Yes, we can see your screen now.
Right. To start, right?
Yeah, you're free to start.
Perfect.
Thank you.
Thank you, everyone, for joining today's meeting and user group. And I want to say special thanks to Claude Study Network, especially Karen, for giving me a chance to share my experience with this community. By the way, my name is Jean-Joseph. I am located in New Jersey, originally from Haiti. I've been in IT for over 17 years. I started as a network administrator. Then I moved to database administration and development. After that, I moved on to database engineering. This is my blog, bigdatadriven.org. I have a couple articles there. You guys are free to go and take a look. And then if you guys want to have any specific question, feel free to email me at jjoseph@bigdatadriven.org. Also, let's get connected on Twitter. This code is my LinkedIn. You guys can scan it. And then, let's get connected. Enough about me. Our agenda for today is how to handle DynamoDB provision throughput capacity doing data load using Python Boto3 library, correct? So you guys, if you are familiar with DynamoDB, you know what is thwarting exception or provision throughput exceeded exception, can occur, right? And then the impact it can cause doing that exceptions, especially if you are not using AWS SDK, or if you didn't set up enough write or read capacity throughput, right? Everything that I'm about to do is mainly related to provision, not on demand, and I will explain it. What is DynamoDB? This is the question most likely people ask when they are going DynamoDB. They want to know what is DynamoDB and also what they can benefit from DynamoDB. DynamoDB is a global distributed key value and document NoSQL database that delivers single-digit millisecond performance at any scale. It is specifically AWS Cloud Citizen NoSQL architecture. You will never find that somewhere else. It's only on AWS. You cannot issue a backup of DynamoDB and restore it from any kind of NoSQL database technology, but except on AWS DynamoDB. These are the things you will need to understand before you even think of moving your application and use DynamoDB as the backend storage. It is fast, scalable by AWS. Support multi-region, multi-master, durable database with built-in security, backup and restore. Moreover, in-memory caching for internet scale application. The reason why I said I need to add the data type also, because that's one of the basic things people ignore. But remember, sometimes some applications depend on a specific type of data type. So meaning you will need to understand exactly the kind of data type DynamoDB support. There is scalar, which is number, string, binary, and Boolean, and null. And then also, there is multi-value. What I mean by multi-value, like array, like string set and binary set. There is also document. Document is list and map. And sometimes if you're doing some data modeling, document can help you create some complex data modeling against DynamoDB. So in general, this is exactly what is DynamoDB. It's a global distributed key value and NoSQL database. So now, how DynamoDB kept your data? This is one of the things you will need to understand. Before you can store your data to DynamoDB, you have to think of a table. However, before you even create that table, there's a lot of things you will need to take in consideration, like access pattern. And earlier I mentioned DynamoDB is a global distributed NoSQL database. So that's mean before you even create that table, you will need to provide a distribution key. The distribution key is the one that will allow DynamoDB to distribute the data across multiple physical servers, if you will. But DynamoDB support two types of them. There's a partition or hash key. This is mandatory. You cannot create any table on DynamoDB without a partition or hash key. One that we call sort or range key, right? So as this is not related to data modeling, I don't want to stay too much on this, but I also want to touch base about anything related to that table. Besides that, there's other things you may need to think. DynamoDB support two types of index, right? It supports local and global. If you heard someone say LSI, it stands for local secondary index, and then GSI stands for global secondary index. Local secondary index, you have to understand If your application requires strong or eventual consistent local secondary index can help you that. The difference is that the local secondary index share the capacity of read and write unit with the base table. You will need to understand that as well. And then also you can only create that when you're creating the table or any extra compute, right? Whereas global distributed secondary index it has its own read and write capacity throughput, and it does not have a limit like local secondary index. Partition can go up to 10 gigs, right? But global does not have that limitation, right? But however, global does not support. So if your application depend on that, these are the things that you will need to think of. Otherwise, you may end up to face some data inconsistent within your application. So after that, let's go to the basic things. Once you create the table, you know the access pattern, you well define your distribution key. If local or global secondary index are required, you create them. So what a table is, inside that table, what content that table hold. In DynamoDB, data are considered as items. So like each row, they call that items. A table is a combination of 0 or more items. Table, you leave it there, there's no items, it's still a table, right? So key is the one that will help DynamoDB to distribute your items. So items is a combination of one or more attributes. That people say that DynamoDB is a no schema database. That's not true. Change it to dynamic schema or flexible schema, because with a single column or attribute, if you will, in DynamoDB, that single table would be the partition key. We still have a structure in DynamoDB, but it is dynamic, whereas in RDBMS, it may require application downtime on production to add or remove a column. But using DynamoDB or any NoSQL database, you have that flexibility. As you can see, the first item have 4 attributes. The second one have 2. The third one have only 1. Because it has only 1, we can only consider this as the partition key or the distribution key, hash key, right? Have 3 attributes on it. So this is in general what you expect and what you should be aware do before you even think of creating any table on DynamoDB. So now you already know exactly the structure of the table, the advantage, the pros and cons, if you will. Let's say if you have one application that only dealing with these 3 attributes, right? Where you have social security number, you have first name, you have last name. If you go, you have no clue how business or application will utilize that database. You go with your knowledge and experience, you may end up to choose the wrong partition key. But if you sit with business or application owner, understand the access pattern, if they tell you in front, social security would be the primary access pattern, it would be very rarely we may even get the data based on first or last name. So that's mean if we use social security as a distribution key, there will be no redundant, no duplicate, because a social security numbers cannot belong to two persons, to two people, if you will, right? So if you look at this, using social security number as a partition key, DynamoDB was able to evenly distribute the data. But if business or application owner, say, for example, care about social security, is about first name, that's it. We don't care about last name, we don't care about social security. Find a way to make that possible. If first name would be the partition key, this is how DynamoDB will distribute the data. As you can see, first name repeat twice. Because first name repeat twice, so that's when there's one partition will require more read or write capacity, throughput, to access that data. This is what we call data skew or hard partitions. It's always very important to think that access pattern must be your number one priority during the table creation, because if you don't, it will not only hurt performance, but you will have to pay a lot of money for that. And then you may end up to have thwarting exception, which can cause data loss or slowness. But we're gonna talk more about this later. So what would happen if the same thing, they said, I don't care about social and first name, all I care is about last name. So if you analyze the data, we already have last name repeat twice, we will still end up to have hard partition. So guess what happened? We have data skew again, which can cause a lot of issue. So meaning choosing the right partition will not only bring performance, but also it will help you save a lot of money. Because DynamoDB, once DynamoDB will distribute that data, because you choose the right partition key, you will help DynamoDB to evenly distribute that data. This is more about distribution. I'm going to show you a simple demo. Give me 1 second. Let me bring my Visual Studio. Able to see my Visual Studio, Karen?
Yes, yes, we can
Perfect.
see your Visual Studio ID code. Right.
Perfect. Perfect. So all I'm doing here, I am in Boto3 library. I'm creating a session from Boto3 using my profile name. I already configured that profile. And I'm calling DynamoDB as the resource. And then this is the region. I'm going to create table 1 first. So from DynamoDB, I'm calling the table, pass that table name, and then I'm defining the parameters. This is where I would love to make you understand DynamoDB do have a schema. So this with distribution key, if you remember, you can call it partition key or hash key. And I created a range key, but this is optional. I could have created a table just like that. Sorry. Right? And then comment this out me as well. I will still be able to create it, but I won't be able to create any table without attribution key. So that's mean there is schema on DynamoDB. So I'm doing here, right? This is the schema. This is the definition of the attribute, right? Numbers and then S for string. This is the provision throughput. I'm gonna start this with 5 read capacity and write capacity units. Here, give me 1 second. Absolutely no tables here. Let me copy this. Let me use Python. Okay, so before I execute it, let me finish to go to. So what I'm doing here, I'm calling the same DynamoDB, and I said I want to create the table and pass that value there, the parameter. And I want to know the status, and then let me know once it's created. Just wait until the creation is completed. So that's been available. So if I execute this, what happened? Did I do something on my screen? Wait 1 second. Okay, so let's wait until it says creating the table. If I come here, refresh it, I may see this. Okay, it is still, let's wait. I'm not sure why it's taking so much time. Okay, perfect. So if we come here, it's creating. So that's when it's not available. As you can see, the total read and write capacity, as we mentioned from our scale, right? So let's wait until the table is available. Perfect. So that's when the table is available. Great. So let's give me a second. So that's me. Anyway, the table is available. For some reason, I'm not sure why it's taking that long. Okay, perfect. Let's carry on. So now, let's say if I have this job, I set up this script on my AWS Glue jobs to load the data coming from S3 to DynamoDB, right? There's something called, if you use SDK, people who are familiar with DynamoDB know there is something that called max attempt, where, for example, whenever there is thwarting occur, AWS SDK where it will retry. So that will slow down the loading part, but it will prevent you from data loss unless if you reach the max. In order for me to illustrate that, so I'm gonna put max attempt to 0, because if you are not using AWS SDK, that would be your default. But if you are using SDK, that's when you have you're gonna use the default one from AWS, correct? So let me walk you through that script. I'm importing Boto3, and I'm importing the config file from Botocore. I need access from my OS directory, and I'm importing CSV. I'm gonna edit the config file on the fly for this specific session instead of change it globally. I'm gonna put this 0. Consider this we didn't use SDK. I just want to illustrate how thwarting can occur. So give me a second. So here, what I'm doing, I'm defining the same session, passing that table which is this table. We just created the table, right? This is the file we will be loading, and this is the function that we load. So all I'm doing, I'm checking if the file exists. If it exists, I want to get that file, remove the header from that file, and then load each item with each row within that file. Right? So and I want to, point in case if it's okay. So now this is the flow. I still have to double check if the file exists, because I don't want to execute all my code and if the file does not exist, even though if I maintain this from the functions, but I still have to do this, because if I share my functions with somebody else, so that logic must be there. Right. So I'm going to do, in order to simulate throttling, I'm going to execute that file. Let me say Python. Before I execute it, I want to show you we absolutely have no items. There is 0 item there because we haven't loaded anything yet. It is very slow. Right? We have no item, even though if we say start search. And then what I want you to understand, if we go to matrix, say again, that's, if we go to matrix, so that shouldn't be there, but that's fine. It might be, that's fine. Okay, so here, I'm gonna load that data. So let's load it. So the data is loading. If I check here, again, let me go to item. I'm not sure if this is because I'm presenting, that should, go very fast, but let's give it a second. Perfect. So now we're able to see the data, right? And then if we go to matrix, I think we must be able to see the good one now, but that's fine. Probably come from I was testing this demo, right? The data is still available from CloudWatch. That's the reason why I have it. So let's go and then let's watch what will happen. So while loading the data, if the workload require more reader, because we're loading the data, capacity throughput, once we reach to that, we will see that process failed. So as you can see, the process failed. The reason why it's failed, it says provision throughput exceeded exception when calling putting operation. And then max retry is 0. So we're gonna increase max. So when you increase max, let's say if you are not using SDK, AWS SDK, it has a default. But if the default, for example, is 20, if the retry reach above 20, you will face the same issue, which can cause data loss as well. But at least you have it. So let's put this to. Once we put this to, so what happened? This will slow down the process, but at least you have 2 times you can retry. So let's keep it that way. and see what will happen once it reaches to above our capacity to put. Thwarting exception will occur again. So as you can see, even though if I pull it 5, 10, because the load is too much for that capacity unit, so guess what happened? It failed. So they said max retry is 2. Our slide deck. What is DynamoDB throttling? Throttling is an internal reject of a request. It's occur when your concurrent execution count exceed your concurrency limit. Thwarting occur when the provision read and write capacity on a table or index exceed the consume amount. In other words, for example, when you issue a request, that request being blocked due to a read or write frequency higher than the threshold you set, you will end up to have DynamoDB thwarting. For example, you will see exceeding set provision capacity, partition splitting. This is specifically related to a hard partition for index and table capacity mismatch. Let's analyze this together, correct? Let's say we provision 6 throughput capacity, right? When our ETL kicking, there's a peak. That peak goes above slightly 8. So guess what happened? Because you provision 6 capacity, and then your process require consume above 6 capacity unit, guess what happened? Thwarting occur. So when this is occur, there's data loss can happen. We're gonna talk about this later. So this is in general. That's why, for example, you need to monitor your consume capacity, because the consume capacity is the one that will tell you how to set DynamoDB read and write capacity throughput unit. So now, as I was speaking about throughput and read capacity, so what I want you to understand, you can create it under 2 read or write capacity mode. It can be either provision or on demand, right? On demand, for example, we're gonna talk about this, but our agenda for today most likely, how can we handle that issue during the data load? So let's keep it simple. Provision, allocate limit for your read and write capacity unit. You pay for what you for that limit, fixed limit, even though if you didn't use that capacity. Let's say if you set it up 50, you only use 10, you still have to pay for 50. It supports auto scaling to dynamically change the provision limit, but thwarting can still occur during auto scaling, because auto scaling have to rely on CloudWatch data. Doing that before auto scaling can kick off, probably 1 or 2, 3 seconds, 5 seconds, that can thwarting can occur, and then you pay per hour. That's the difference. Whereas for on demand, there is absolutely no limit. You pay per request. I would highly suggest you, if you just create a table, if you know, for example, the load, it would be better to start with provisions. But if this is unpredictable, you have no idea how much read and write capacity throughput unit that require for this table, it would be better to leave it on demand and then monitor that for 1, 2, 3 weeks or 1 month, right? And then bring it back to provision and set auto scaling in order for you to save money, because on-demand pay per request, which is kind of more expensive, but you have no limit. So now we come to a point that we know how DynamoDB kept our data, how the distribution done, and then if we don't have to retry, we may end up to have data loss and our process can fail. ETL process may fail as well. So now, what can we do from our hand to maintain that? When that job was failing, it was hard for us to pinpoint. We monitor it. We know it is struggling, but because of money, they don't want to increase that. Even though we set up for auto scaling, it still requires a minimum and a maximum, and we already know exactly how much throughput we need for read and write capacity. So they asked me, they said, come up with a way to handle this situation. After analyzing the process and then understanding the error message, if you let me go back to that error message, said, consider increasing your provision throughput level. And I analyze it, try to have a good sense of it, and then see what can I do to prevent this. That's when I came up with these steps. This is for my end, right? And that's how I did it to resolve it. It may help the community, but if someone find a better way, feel free to share it with us live, and then we can discuss it. That's my way. So what I did, I used Boto3 library. We're already familiar with this, right? To get the metadata of the table configuration, I save the value of read and write capacity unit into 2 variables, because you cannot update one and leave the other. Let that happen. So what I'm going to do, I'm going to increase throughput write capacity unit before I load the data. So once the data load completed, it doesn't matter if it's complete successfully or completed with error. We still have to update production back to the way it was. So what happened? So at the end, we're gonna have to bring that value back to the value it was before we increase the capacity of it. Of what unit capacity. So let me go and demo this. Before I start with this, Karen, I would love to know if there are any questions.
Jean, as of now, there are no questions from our attendees. I only have one question, and this capacities which you set in the AWS DynamoDB read and write capacity. This is a kind of you can change it, of course. It's a kind of variable, but if you will have a front-end application attached to this database, and the traffic will grow, like there will be some sparks of traffic. It should there should be, like, there can be a problem because of this capacity, right? If you didn't predict this kind of spike of the traffic, it could be that you cannot serve all the requests. Is it correct?
Right. The capacity is the capacity. Read and write capacity measure your workload. You understand? It's like a compute, right? For example, if you have, let's take this. If it's like, for example, if you have 10 gigs on your machine of RAM, you cannot load 11 gigs on it. or 15 gigs
Yes.
on it. So it set a limit. You understand? Right.
Yes. Yes.
So that's mean what the capacity throughput define your workload, how much workload you can handle for any given capacity. Does that answer that
Mhm.
question, or do you want me to provide you
Yes.
more detail?
No. No. Actually, yeah. But it may basically means there are limitations which you have to predict from the beginning once you set up the DynamoDB in the AWS. Of course, you have this another option which is auto scaling. This is a very elastic option. You don't have to care about it. But as we saw, it is probably has a higher price tag because it's not included in the free tier, which you can get for free for 1 year for, of usage for AWS, but it's excluded there. So basically, once you go there, you have to pay obviously a little bit more.
Right. Even though you do have auto scaling on, you may end up to face that same issue because auto scaling rely on CloudWatch data, and I have faced that. So by the time auto scaling kick off, to realize that, so guess what happened? There's thwarting exception. It's happened once in a while. Auto scaling is great. That's the best way to maintain it, right? But at the same time, you have to think of this as well. There's a 4% of thwarting, even though you have auto scaling set on.
Yeah, obviously. So yeah, thank you. That's what it was my question. Let me check again if we have any other questions. No, as of now. Oh yeah, there is one question. Thank you for your
Right?
speak. Can you share the concept why we need to make Dynamo load data by Python in MongoDB? Or can we have this library Dynamo load data by Python on Amazon MongoDB? Do you understand the question? It was
Does that person refer to document DB, or
the,
does it have
it,
Mango
yeah,
DB?
let me just post you this question into the chat so that you
Let me
can
see.
read it yourself
Right.
really quickly.
Yeah. Can you share the concept why we need to make Dynamo? I'm I, I'm not really clear about the question because the thing is when I'm looking at the question, is something AWS provide us to use to utilize their resources, right?
Hmm.
When I'm seeing MongoDB, right? MongoDB is a document database, right? Which is kind of different than DynamoDB because MongoDB I can do group by, I can do all kind of analysis, right? I can create index, I can treat it just like RDBMS. Whereas DynamoDB, you can't do that because DynamoDB behind the scene is just a single table, correct? Architecture.
Hmm.
So which use the distribution key and the global secondary index to do complex data modeling, right?
Hmm.
So meaning when I'm seeing that question, I'm not sure exactly what I have to say, but if that person can be more like precise, I'll be happy to provide my input. But for now, I don't think because it doesn't matter if you are using MongoDB, you still need the client to communicate and to load that data. You still need kind of API, correct?
Hmm.
Right. Do you understand it? Is there somebody? Can that person be more precise, if you will?
Yeah, Bill Chong, if you want to put your question in the more precisely, feel free to do so. We have a few moments for this. Yeah, like MongoDB is not obviously it's not a native service within Amazon Web Services. You can of course have an instance there. Like you can put any almost like any open source database or sometimes also proprietary databases into AWS. But yeah, if you want to specify your question more precisely, feel free to do so. Otherwise, we can clarify it later if it's
Right.
after the talk.
Any other question?
No, as of now, there are no other questions. So it's also a message to everyone. If you have any questions whatsoever, feel free to post them in this chat in uh, in the stream, and we will address them basically.
Right. Okay.
Okay. So
Thank
as
you
of
so
now,
much.
there are no more specifications, no like other questions. You can proceed, and we can have another break uh, after another section to clarify the questions.
Right. Thank you so much.
Okay.
Right. For this one, I specifically mentioned this. This is specifically if your table set on the provision throughput, correct? So I already walked you through the steps. What I'm doing here is doing the same thing. We are familiar with this from our previous scripts. And I will not increase this. I'm going to leave this for example 0 and load the whole data and see what will happen. And then this is the same thing from previous scripts. The only thing I'm doing here is for the demo purpose, I'm using input variable. However, from your glue, it might be coming from a database tables, right? It might be hard code as well. So this is just for the demo. So this is the one that I will increase, right? The write capacity before the data load. This is the same functions. The same function we just went previous script. This is a new function. So all I'm doing from this, I'm telling DynamoDB I need the metadata, I need the client. From client, I need the update table. So all I need is update, provide the new read or write capacity. That's all I'm doing. So here is the same thing. I'm checking to see if the file exists. But there is more logic here. So here I'm getting that I'm telling DynamoDB I still need the client metadata, but the type of data that I need is the describe table. I need to get that information because describe table will give me all the table configuration, the size, number, rows, and everything. But the information that really matter for me is that table. Within that table, what I really need is the provision throughput. So that provision throughput, okay, so that value will be saved here, right? So I just initiate two type of variables, one for read and one for write capacity, and I'm saving them here. Debugging purpose, I'm pointing that data. However, within my workload, the data goes straight to CloudWatch because we need that data for troubleshooting purpose. Right. Below, I will mention what I was about to say. So initial value. And then what I'm doing here is calling this function, keep the same read capacity because I'm not changing, I'm loading data. I need write throughput, not read throughput. Increase it. I'm gonna that input variable from here that I want to increase, correct? Okay. So now, once I update it, I want to give DynamoDB sometimes, because if you don't give it sometimes, you just you may end up to have thwarting. This is the reason why, Karen, I mentioned, even though if you have auto scaling, by the time auto scaling kicking, increase your throughput, thwarting can occur, right? So all I'm doing, I'm telling the process to wait for 5 seconds, give DynamoDB enough time, the underlying backend table configuration, and then I still have to make sure the change has been occurred successfully, because we don't want our ETL job to fail. So what happened? This value back to write and read capacity unit variables, and I compare the write capacity. So that's been, if this one, which is the latest data coming from provision throughput type table, so that's mean if whatever input value I pass, if it's equal to that increase write capacity, so that's mean the change has been occurred successfully. As the change has been occurred successfully, so guess what happened? I want to point this. However, we sent this to CloudWatch, and I want also to load the data. So even though if I load the data, if the data completed successfully, or if the data completed with error, I still have to revert it back. So this is not what matters for us. What matters for us is this one, because we change production configuration in order to prevent business processes from failing, right? Or data loss or occur, but we still have to make sure that we bring it back. So even though if the process failed or not, we still have to change it back. So what I'm doing here, after we change it, I want to wait for at least 5 seconds, and then point that value, and then say done. If the file does not exist, we send that information to CloudWatch. So what happened? There is a lambda will go and change, for example, the execution time. So because we are receiving the data from other client, they don't have the exact time, right? We set up a lambda, but at the same time, if the job run, so guess what happened? Because of dependencies, we have to deal with data on premises, data from other VM. It's kind of complex, but we still have to centralize everything. So once that data goes to CloudWatch, there's another lambda can go and modify the appropriate change in order to facilitate this job to run again. So what is that? Remember, it is the same file, even though we increase it from previous file, it's failed. So before I load that data, let me create table 2. So I'm going to use the same script. This is 2. Let me execute this script again. Create table 2 with the same capacity to put. As you can see, the table is creating. Go here. Okay, the table is active, so that's when we are ready to go. So now, perfect. Let's go and load that data to table 2. So let's copy this one. Okay, let's execute this. Okay, this is the input. Let's pull it, for example, 50. So that means, so we insert 50. If you're looking at the read capacity is 5, the write capacity is 5. That's the initial one. We're proceeding with the data load. Write capacity is 50. And then if we go back here, this is kind of 5. If we refresh it, this will be 50. So now we're gonna watch the data. It might take a couple seconds. Can you verify, Karen, if there are any other questions? So this way we can go over that.
Yes, let me see. Well, as of now, there are no more questions. I
Great,
think we can proceed.
perfect. So the data is currently loading, and then if we check, we will see the table is loading. We must see data there. Yeah. For some reason, I'm not sure why. So like that, but let me go back, complete it. So like, so it's still loading. As we can see, we see data there. Can even analyze it, but unfortunately, I just 1 hour early before we start with the presentation. I already load the data. We may end up to get information coming from CloudWatch. I would show you the goal of the pattern. Right. So let's go back to this and see. As you can see, it is completed. You see, after it's completed, it's bring the value back to 5. If we check, remember the value was 50. The value was 50. If we refresh it now, it would be 5 now, with no issue. And then this is just doing the ETL process. I know auto scaling would be great, but like I said, you may end up to see, and then that's the reason why I mentioned it here as well. Give me a second. If you remember, anyway, from previous session, and I mentioned it. Right. As you can see, everything went well successfully with no issue, and then we bring it back the way it was. So now let's go back to our agenda. Key takeaway is that excessive throttling is caused by sometimes hard partitions or insufficient capacity throughput. What I mean by hard partitions occur, as I explained earlier, when you choose the wrong partition key. Because partition key is the one that will facilitate DynamoDB to evenly distribute your data. If you didn't choose the right partition key, you may end up to have a lot of issue, not only cost, but there are some other issue may occur as well. For read and write capacity unit, right? In order for you to really well define that, it would be better to start with on-demand. for 1 week, 2 weeks, or even 1 month. Analyze the flow and then come up with a minimum and maximum read and write capacity unit and set up auto scaling, right? The side effect of that is that if excessive throttling occur too much, there's tons of issue you may end up to face. You may end up to have data loss if your application failed to retry, right? Execution time will be very slow because for each retry, right, it will increase the time. And then you still have to think of the maximum of retry, right? And then data can become out of date if write are throttling, but read are not. These are the things that you must be aware of. And then I want to say thank you to everyone. As I already introduced myself, if you guys have any question, please throw it now. And then also feel free to get connected with me. This is my LinkedIn code right here. And then this is my Twitter. You can follow me. And also, if you have any question, feel free to email me at jjoseph@bigdatadriven.org. Karen, please let me know if there are any other questions.
No, no, everything is quiet. Everybody is very much attracted to your presentation and listening carefully. There are no questions as so far, but I'm directing it to all the attendees. If you have any questions whatsoever, it's about the right time to ask them and have a discussion if we have any questions related to this topic. While we are waiting, maybe we will get some questions in. I have a general question about DynamoDB. So I really liked your introduction to the DynamoDB as one of the AWS services and also a type of a NoSQL database. Really great. Thank you for that. What do you think? Is there any easy way, like if you are building your application on top of this backend, then DynamoDB, obviously based on AWS, but if you want to migrate to any other cloud provider or like self-hosted, maybe with Kubernetes on premises somewhere, do you think it will be difficult to migrate your solution? Do you have to change the code a lot, the whole concept of data storage? Or is there any service or any support provided by AWS to make this kind of shift easy? Or maybe there are any open source solutions which you are aware of, which can kind of help you to migrate?
Right. What I want you to understand, the application front-end feature is what will drive you what type of database you should migrate. Because remember, DynamoDB is a single table schema design, right?
Mm-hmm.
So meaning there are some DynamoDB does not design for all kind of application, right? But it is designed for a specific type of application, right? Mm-hmm. For example, like IoT device, web device, web application. I mean, and because what I want, let's say if your application, right, DynamoDB is just a backend data to me. When you mention if you want to migrate your infrastructure, so meaning there will be code changing because if your infrastructure is typically based on RDBMS, so that's when within your code, like function, procedure, any database object, queries, views, synonyms, you may end up to have a lot of join. So all of them will need to be reviewed. These are the things you will have to know, because you cannot join DynamoDB tables, right? And then you cannot execute distinct order by, because the data is distributed across multiple physical storage, right? You cannot group by. There's so many things you have to think of before you migrate it. It would be better to understand, how your front-end application will communicate with the backend of the data storage, right? Because migrating to AWS, migrating the data is easy. We can write some code, get the data from SQL Server, load it, but the front end will have to redesign. That's not something very likely, because I was part of two projects. It required a lot of work, especially at the front end development stage. So meaning I'm not sure exactly what kind of your environment is. It SQL, Oracle? What kind of RDBMS is that?
Well, we would speak, for example, about a kind of NoSQL database on the back end. I think MongoDB, there was a question about MongoDB as well during the presentation from one of the members. I think it's really very popular, but as you said, it's very much depending on the type of the application, how the data storage is happening. Is it an IoT device, or is it like something else? Because you said you have to predefine the schema, right, with
Right.
MongoDB. And one of the advantages, like general advantage of many NoSQL databases, is that you don't really have to care about schema so much in case of MongoDB, because you can define whatever like fields you will get. You can just start creating new fields along the way. What seemed to be troublesome or not like designed to be this way with DynamoDB, right?
Uh, they kind of, if you think of it, there are some a little bit of difference. For example, if you like to maintain your environment, you have strong people to maintain MongoDB. MongoDB, when it comes to application feature, is more give you better flexibility, because we all know SQL. And there is so much feature for that. Even though I'm seeing, AWS doing its best to bring feature to DynamoDB. But when it comes to managed instance, I think DynamoDB is a great database to think of. Not only it gives you the schema flexibility, there's something called multi-master, where where you can bring the data closer to your client or your audience, if you will, right? So meaning, and then if you know DynamoDB well, you can kind of design the same type of data modeling you already have on your RDBMS system by the help of global secondary index, if your application does not require strong, consistent. But this is something, if when it comes to flexibility, data manipulation, data analysis, I would go with MongoDB. If this is typically OLTP, I would go with DynamoDB, because for performance and cost saving, DynamoDB would be number one for OLTP. But for anything related to flexibility analysis and stuff like that, right, where I don't think DynamoDB would be the best choice for you. I'm not sure if you have anything you want to add on top of that, but that's just my understanding.
Mm-hmm. Yeah. Thank you very much. It's a very clear. Yeah, I'm just checking
Thank
the
you.
questions. There is nothing else, what people would like to ask about. So yeah, that's. I think it's very interesting presentation, and many people, because we announced it today, just today, we didn't announce it like properly in advance. I think many people will be watching the recording, what is really nice. So, and everyone who is watching right now, you can watch this session anytime on demand afterwards. It will be the same URL. You don't have to search for the link. It will be the same. Yes, John. So, is there anything to be added to your great presentation, or what other topics are you interested in? What other services of AWS or anything else you are exploring?
Right. I have good experience in Redshift. If you want, I can have a session where we can load live data to Redshift from AWS S3 or from DynamoDB as well, or from Redshift to DynamoDB or DynamoDB to Redshift. How can you maintain that dynamically using Lambda?
And the Redshift is a managed SQL database, correct?
Yes, it is RDBMS, but more like analytical database, data warehouse database.
Okay.
Yeah, AWS data warehouse Redshift.
Well, it's absolutely interesting topic actually for people like you, for your colleagues who are data scientists. Very amazingly interesting. So yeah, let's get together afterwards and see when we can run this kind of session as well about the Redshift.
Sounds good.
Great.
Thank you so
Okay.
much,
Yeah,
Karen.
you're welcome, John. You're welcome. I'm checking for the last time the questions, and there are only like thank yous to you, John, and also to all other members who managed to attend today. We did have about, I don't know, like something like, let me see, about 16 people at most. Right now we have 12 people watching it, and I'm pretty sure there will be much more people who will be watching the recording.
Right.
Okay, great, Sean. Thank you very much again. It was a great session. I enjoyed it very much, learned new stuff. I hope it was also very helpful to our attendees. Yeah, so thank you. Thank you very much.
You are very welcome, Karen.
Yes. With this, I'm going to stop the stream. Jean, you can stay for a couple of minutes longer. Thank you everyone again. Take care. Have a nice rest of the weekend, and see you next time. Bye bye everyone.